Hello everyone, and welcome to today's session. My name is Reese, and I'll be your host and moderator today. We are just waiting for a couple of minutes so that everyone has a chance to join before we get started. We will be starting at the top of the hour. If you haven't seen already, we do have a couple of prerequisites for this session if you want to code along live with us. Namely, those are you need to set up your own MongoDB cluster, you need to obtain a Voyage AI API key, and you need a Gemini API key as well. These instructions are on the registration page, so you'll be able to find those either in the video description if you're on YouTube, or you'll be able to see this as a comment on YouTube. But yeah, head over to datacamp.com/webinars, find the registration page, and those details are in there. They will also be in the notebook that we have for this session as well. So we're going to be using Data Lab today. So please check out the resources document and the notebook link that I'll be showing in the chat very shortly. So yeah, check those out in the comments. If you're on LinkedIn, we don't have hot links, so you will need to copy and paste the links rather than just click them. But yeah, if you're on YouTube, you will just be able to click the links. If you're on YouTube as well, please do subscribe to our channel, and also please do drop a like on the video as well. Brilliant. I will be back in a second to repeat these messages, but yeah, give me any heads up in the chat if you don't see any of the documents that I previously mentioned. Hello everyone, and thank you for joining today's session. My name is Reese, and I'll be your host and moderator today. We are going to get started very shortly. If you're not aware of the prerequisites for this session, they are on the registration page. I'll be posting that in the chat very shortly. Actually, I'll post it right now. We do have a couple of prerequisites, as I just said. So you need to set up your own MongoDB cluster. You're going to need a Voyage AI API key and a Gemini API key as well. Those details are on the registration page. I've just sent the link so that you can have a look at those. However, you should have received these instructions via email if you did already register for this session as well. So please do register for this session if you haven't done so already. That means we can send you the recording and the resources as soon as they are live on our resource center tomorrow. We are going to be sharing a link to the notebook during the session. So yeah, if you want to code along live, then please do check that out as well. Okay, I think that's everything. So now I will appear on stage and we'll get started. Hello, everyone. Hope you enjoyed the music today. Usually Richie is not a fan of the music that we play on the lives, but he's not here to complain. Obviously, he's not here at all. He is still out hiking the Appalachian Trail. So if you're in that area and you find a man without a flashlight, that's probably Richie making his way down the trail. Now, today's session, for many business use cases of generative AI, the biggest challenge of getting high quality results isn't advanced reasoning. It's getting the right context and information to solve your problem. Retrieval augmented generation, or RAG, is a standard approach, but there's a lot more that you can do. You want a model and embeddings that understand your industry jargon. Beyond this, you want to be able to work with data in whatever format it appears in, whether that's text or images or audio. So today we're going to learn how to build multimodal AI applications. Our instructor today is Apoorva Joshi. I'll bring her on stage now. Welcome, Apoorva.
Hello, nice to be here.
Fantastic to have you. Apoorva is a senior AI developer advocate at MongoDB. She began her career as a data scientist and has over 7 years of experience applying machine learning problems. Applying machine learning to problems in domains such as cybersecurity and mental health. As an AI developer advocate at MongoDB, she now helps developers be successful at building AI apps through written content and hands-on workshops, just like we're having today. So yeah, over to you, Apoorva.
Awesome. Thank you so much for the intro, Reese. I think I have a bunch of slides to kick us off just to set the context for what we are building today. And then we are going to spend most of our time, you will spend most of your time hopefully building a multimodal agent from scratch. And if you don't feel like coding along today, I'll at least I will be coding, so you can at least watch me and try to understand what's going on. So with that, let's jump right in. So thanks everyone for being here. Um, drop a note in the chat. Tell me where you're logging in from. I love to see all the different places that people are tuning into my sessions. So drop a hi. Welcome to today's Code Along. So in the next 45 minutes or so, I'll be talking a little bit about the concepts of multimodality AI agents, and then we are going to be building a multimodal agent from scratch using MongoDB, Voyage AI, and Google's multimodal Gemini models. So let's jump straight in. Okay, so not going to touch too much on AI agents. Reese will be linking to a few resources that help you build up those basics. But without getting too deep into the theory, let's briefly talk about what AI agents are, and we'll focus a little bit more on multimodality since that's the crux of what we are building today. But to begin, what an AI agent is, here's my definition. It's a system that uses a large language model, I'll be referring to those as LLMs, to reason through a problem, create a plan to solve the problem, and execute and iterate on the plan with the help of a set of tools. The other thing we need to understand today is multimodality. We are building a multimodal agent after all. So what is multimodality? So multimodality in the context of machine learning and AI is the ability of machine learning models to process, understand, and sometimes even generate different types of data, such as text, images, audio, video, and so on. And in today's lab, we'll be working with two of these modalities, which is images and text. And here are some real world examples of data that contains a combination of images and text, just to give you some inspiration for the type of problems and domains you can apply your learnings from today to. So think things like research papers, financial reports, healthcare documents. The list is basically endless because you find documents like these all over the place. Now, to make sense of this type of data, we currently have two classes of multimodal machine learning models. And the first type of models we see are multimodal embedding models. The job of these models is to basically take multiple types of data, such as images, text, audio, video, and generate embeddings, which is an array of floating point numbers, so that all of these diverse data types can be searched and retrieved together using techniques like vector search, hybrid search, and so on. And the other class of models is multimodal LLMs. And these models can understand, interpret, and even generate different modalities. And we'll be using both of these in today's code along. So now, given a multimodal LLM, tools to search through multimodal data, and use its reasoning capabilities to make sense of this information to solve complex problems, what you have is a multimodal agent. And that's what we are building today. So let's go ahead and build one. Let's talk a bit about the objectives of the agent we are building today. We are going to start with something that sounds simple. The agent is going to have two simple objectives. The first one being answering questions about a large corpus of documents, and also given a chart or a diagram, it's going to help the user make sense of it. Sounds pretty simple and reasonable, right? But there's a slight catch here. The documents you are working with are going to have mixed modalities, which means they have text, images, and tables interleaved with each other. And this complicates things a little bit because retrieving the right information for your RAG applications or AI agents from this kind of data is not a trivial problem. So we'll be focusing on the data preparation aspect of our agent quite a bit as well in today's code along. The challenge basically lies in preparing the corpus of documents for search and retrieval. So typically for text-based documents, you chunk them up and then you retrieve relevant chunks to pass as context to an LLM. But you can't really do that when you have images and tables in your documents as well. And one way to do this is to use machine learning models such as vision transformers or OCR models to identify and first extract the different elements, that is text, images, and tables from your documents, then you maybe chunk the text as usual, but you have to do something like summarize the images and tables and then create embeddings of the text chunks and the summaries so that you can do things like vector search on all of this data. So as you can see, this can make for a pretty complex data processing pipeline, because you need an OCR model to extract all the elements, another LLM call to create summaries, in addition to chunking and embedding, which are already one too many steps. But in today's code along, I'm going to introduce you to this class of embedding models called VLM-based embedding models. VLM here stands for Vision Language Models. So basically, in these embedding models, both text and images are vectorized using the same encoder, which means that text and visual features are treated as part of a unified representation rather than distinct components. So with these models, all you need to do is take a screenshot of a document containing interleaved text and images, and the model will ensure that the contextual relationships between the visual and textual information is preserved. So as you can imagine, this greatly simplifies the data processing pipeline for multimodal data and also ensures better retrieval quality, since you're not separating the texts and images from each other. We'll come back to this later, but for now, I'm going to move on to the coding portion of this code along. So if you haven't already, I would say open up your data lab notebook, because that's where you're going to be working in for the rest of this session. So the first thing we want to do, okay, let me step back a little bit. So what we are going to do for the rest of the session is we are going to build that multimodal AI agent from scratch. So the first thing we want to do is install a bunch of Python libraries. I'm working in a Jupyter notebook, and I'm going to directly install these libraries using a pip install from the notebook itself. So I'm going to install PyMongo, which is the Python driver for MongoDB. I'm going to install Voyage AI, which is the Python client for Voyage AI. And Voyage AI is our preferred vendor of choice for embedding models. Then Google Gen AI, which is the Python library to access Google's embedding models and LLMs via Google AI Studio. And we are going to use Google LLMs today, so we need that. And then there's PyMU PDF and Pillow. These are basically libraries. The PDF one is for analyzing and manipulating PDFs, because we are going to be working with PDF data or PDF files, and Pillow, which is an imaging library, because we are going to be taking screenshots and working with images as well. And then TQDM, which is just to show progress bars for loops in Python. So if you look at your notebook, it's going to look a little different from what I have here. You basically have everything filled in. So for today's code along, just try to set up your prerequisites and run the cells in the notebook. I just personally find it harder to keep up with someone talking to me and also filling in my own code, especially when you're working in like a 1 hour time constraint. So, which is why I provided a notebook that's already filled in, but I definitely encourage you to take a closer look at it after this code along, maybe add on to it and really get a good feel for what's happening in there, even if you can't fully grok it in the next hour. All right, so let's go ahead and run that. Okay, initializing. All right. That's going. And yeah, if you haven't set up prerequisites, highly encourage you to go do that right now, because you're going to require those prerequisites to be able to finish running the notebook end to end right now. All right, so importing these two, this is just to securely enter environment variables and such. So at this point, I'm going to start pasting in some of my own code. So the first prerequisite we have is to create a MongoDB cluster. So for that, if you don't already have a MongoDB Atlas account, you're going to have to do that and then spin up a cluster. And for the purpose of connecting to your cluster programmatically, you're going to have to obtain the connection string. And I'm going to assume that you already have a cluster. So for now, I'm just going to show you how to obtain that connection string. So this is what my MongoDB Atlas UI looks like. I've already registered for an account. And here's a list of the clusters in my account. So I want to connect to this cluster. And here's that connect button. So I click on that. And I want to connect via drivers and the Python drivers. So I'm going to click on drivers, and this is basically my connection string, which I'm going to copy and paste here when it says enter your connection string. So I'm going to run that code block. It's asking me for my connection string. Here's where I'm going to paste that. Okay, sweet. The next thing we want is a Voyage AI API key. So we are using embedding models from Voyage AI, and the way to do that is via their APIs. So you need an API key. So for that, I've dropped a link here. Click on that. That should bring you to this page. And it should tell you how to obtain an API key. Basically, you go to the Voyage AI dashboard. And if you don't already have an API key, select create new secret key and create one. I already have one, so I'm just going to use that. So going back here, going to run that. It's asking me for my key. So let's paste that. Cool. And the other thing we are going to need is a Gemini API key. So we are going to use a multimodal LLM from Google's Gemini suite of models. And the way you use those is via their APIs. So we need an API key here as well. I've dropped a link to that up here as well. So go there. That should take you to their developer documentation. And it'll ask you to go to Google AI Studio to grab an AI key. This is my Google AI Studio. So again, if you don't have an API key, click on that. I already have one. Just going to use that. All right. So at this point, I have all my prerequisites set. Now, what we are going to do is, like I said, I want to show you how you would build a multimodal agent that can reason through documents that have interleaved text, images, and tables. But I don't quite have like financial reports or technical manuals. But what I am going to use is the DeepSeek R1 paper. So it's a research paper, and research papers typically have a bunch of text. They have graphs, then they have like this tabular stuff. They have actual tables. So it's a good representation of the kind of documents that you'll see within your organization, like financial reports or any kind of business reporting, really. So I'm going to use that as my sample data set for today. So the first thing, like I said, we are going to focus quite a bit on the data processing part of our AI agent, because this is really the key for your AI agent to be able to get the right information to answer user queries and such. So what I'm going to do is first download that paper and then iterate through each page of the paper and convert that into a screenshot. So basically converting that PDF file into a series of screenshots, and then we'll see what we are going to do with that a bit further down. So first thing, I at least want to read that PDF from, is this PDF not attached to the code along notebook yet, please? So we are going to read the PDF from archive directly, and that code should be under task 2. So yeah, the paper itself is not directly linked, but you are going to download and load it as a PDF. I'll show that to you in just a sec. Okay, so right here. So if you look at task 2 in your notebook, you should see the link to the paper. And we are going to download the paper by making a GET request to this link. We are going to read the content and load it as a PDF using the PyMU PDF library. So that's what's happening in this piece of code. Let's run that. Okay, that's done. So now, like I said, we want to convert this PDF document into a series of screenshots. And you can't directly save images in databases like MongoDB. Because these are not directly optimized for storing large binary files. And no database is going to be optimized for that. But things like blob storage solutions like S3, GCS, I'm sure Azure has its own equivalent. These are optimized for storing large binary files, such as images. So what we are going to do here, or what you would typically do, is store these image files in some form of blob storage, and you would store references, like say you have the S3 bucket, I think they're called URIs. You would store those in a MongoDB document and write that to MongoDB, which is what we are going to do here. But we are not going to write to S3. I'm going to write these images locally, just for the sake of this code along. But in like a production setup, you would be writing these images to some form of blob storage and writing the metadata to MongoDB. So for now, let's run that import first, create an empty list of documents, well, empty list to store the documents that I'm going to create. So here, what I'm going to do is iterate through the pages of the PDF, convert them to screenshots, store the screenshots locally in a prod setup. Like I said, you'd store those to blob storage, and then you would write metadata to MongoDB. Why screenshots when you can read the PDF directly, except if you're reading images? Exactly. So I want to be able to read the images and tables in there, which is why I'm taking screenshots. And screenshots are basically to keep the text and image together, because that is what the multimodal embedding model is going to embed the text and images together, which is why I want to keep them together in a single screenshot. So the first thing I'm going to set is like the zoom. We want the multimodal LLM to be able to clearly see the data that we are giving it. So we want it to be of a certain resolution. So going to set the zoom first and set the matrix dimension for how big the images should be. So that's what is happening here. Now I'm going to iterate through the pages of the PDF that I created here. And then I use the method getPixMap from, again, the PyMU PDF library to render the PDF page as a matrix of pixels, basically. So that's what's happening here. And then I'm going to save this image locally for now. And for each image, I'm going to create I'm going to give it a name. Here, it's just going to be the page number.png. And I'm going to save that file locally. What I'm also going to do is extract some metadata about the images. And this is what I'm going to store into my MongoDB collection. So I'm going to extract the reference or the name of the image file, the width of the image and height. This will be to render the image later on when we need to pass it to the multimodal LLM. And I'm going to create documents that for now contain these three things. So let's go ahead and run that. So as you can see, we have about 22 pages in this PDF. So pretty small documents, but pretty small document for now. But in reality, you might work with a large number of these kind of documents. Okay, so let's make sure that all the pages of the PDF were processed. So we want to see 22 documents being stored in this list after running that piece of code. And let's also go ahead and preview a document to see what those look like. And these are the documents that we'll be storing in MongoDB. So for now, we just have like a reference to each screenshot, the width of the screenshot, and the height. Now, the next thing we want to do to be able to make all of these screenshots searchable is to add embeddings to them. So that's what we are going to do here in task 4. So imports. So here we are going to import image from the pillow library and client from Voyage AI. 22 images, perfect. You are on the right track. And if you think I'm just blabbering random things, it's just me reading through the comments that are coming in. All right, so we'll initialize the Voyage AI client. And this client is going to read that Voyage AI API key environment variable that we set in task 1. So looks like that client got initialized properly. So the next thing I'm going to do is write a helper function that is going to help me generate embeddings using a multimodal embedding model from Voyage AI. A few things to note here. So I'm using the Voyage AI client to connect to their APIs, and I'm going to use the multimodal embed API. This is specifically the API to generate multimodal embeddings, as the name suggests. Now, there's a few parameters to pay attention to. So the inputs will always need to be of this format. So a list of lists. You set the model here. Here I'm using the Voyage Multimodal 3, which is their latest multimodal embedding model. And then you need to pass an input type. So if you're embedding a list of documents to create your say knowledge base, then the input type would be document. And if you're embedding a single user query, the input type would be set to query. And the reason you do that is the model automatically appends like some tokens depending on what your input type is. And this basically generates better embeddings. So let's go ahead and create that function. Sweet. And then, so we created that list of MongoDB documents here. What we are going to do now is iterate through those documents. And remember, if you see here, these documents don't have an embedding yet. So what we are going to do is iterate through these documents and add an embedding to them. So iterate through those documents. Using that reference to the screenshot, we are going to open or load the screenshot first, and then we are going to embed that screenshot. And we are going to store that embedding in a field called embedding in those documents. All right, so I'm gonna run that. I really like TQDM. A lot of folks, you'll see that in a lot of my code, and it's just a nice way to get these progress bars in Python. And it lets you know where your code is at. Okay, so that's going, that's done. All right, so let's preview the document again. At this point, we expect to see all of these fields, but also an additional embedding field. So let's make sure that we have that. I hit this output initially just because it's pretty long. So we have the key, width, height, and we also have the embedding at this point. Let's hide that again. All right, so at this point, we've downloaded a PDF. We've converted that into a series of screenshots, and we've also generated embeddings for these screenshots. And our data is almost ready to be queried and retrieved by an AI agent. So the last step is to write this data to a MongoDB collection. So import PyMongo and specifically Mongo client from the Python driver. Now let's actually instantiate a MongoDB client. So you do that using the Mongo client class, and that's going to use the MongoDB URI that you set in the task 1, which is the connection string to your cluster. And this is a quick check to make sure that you're able to connect to your MongoDB cluster. So let's run that. All right. So at this point, I see a few questions coming in, but I'm going to take those towards the end. So keep them coming. I'll get to them in a little bit. All right, so we've connected to our cluster. I'm just going to set the database and collection where I'm going to ingest these documents. So first thing I want to do is, yeah, connect to this specific collection. So the way to do that is MongoDB client, database name, collection name. And then the next thing is I want to delete any existing documents in that collection. Looks like I had a few, so it's gone ahead and deleted those first. And then I'm also going to bulk insert all of these documents with embeddings into that collection. And the way to do that is using the insert many method in our Python driver. So basically, it's going to do a single operation and insert all of these documents in one operation into my cluster. All right, so if you've built RAG applications, and if you haven't, then basically, if you need to retrieve documents using this technique called vector search, then one of the things that you need to do is create a vector search index. And this basically allows you to efficiently query data using vector search, and MongoDB is no different. So what we are also going to have to do to be able to retrieve this data using techniques like vector search is create that vector search index, which is what I'm going to do next. So I set a name for the index, and I need to create an index definition. So the index definition is usually basically going to contain the name of the index, the type is going to be vector search, and the index definition. And this basically tells the index, again, what type of field it is, and we are going to essentially create the index on the embedding fields. And embeddings are essentially vectors or an array of numbers. So the type is vector. The path is the path to the embeddings in our documents. Then we have number of dimensions, which indicates how many floating point numbers are in our embeddings. And this is dependent on the embedding model used. So we used Voyage's Multimodal 3, which produces embeddings of 1024 dimensions. So that's what we are going to set here. And then the similarity metric, which tells the index how to measure similarity or distance in vector space. And there's a few different mathematical functions to measure similarity. We support cosine, dot product, and Euclidean in MongoDB, and cosine typically works best for embedding. So I'm going to set that. And then I actually need to create the index. So go ahead and do that. Okay, so one note here. So you've created the index, but for it to be queryable and searchable, you need to make sure that it is in ready status. So let's go back to my cluster. Browse collections. Okay, I have a bunch of things, but there's the multimodal code along. So this is my collection. As you can see, it has 22 documents. But what I'm right now looking for is to make sure that my vector search is ready to be queried. So I go to search indexes, and I can see that that vector index was created, and it's queryable and ready to go. Perfect. Moving on. So now we've prepared our data, and it can be queried by an agent, a RAG application, whatever application you build on top of this. So for today, we are going to be building a multimodal agent. So let's go ahead and build that part of it. So basically, the way this agent is going to work is I've included a few diagrams here. So essentially, a user sends a query to my agent. An agent is nothing but a software application with multiple components. Typically, you have a bunch of tools that your agent can call out to get information, and it also has an LLM, which is going to decide which tools the agent should call and process the response from those tools. So yeah, question comes in, agent forwards it to, oh, I think I messed a few things up. I'll need to fix that. But basically, yeah, user sends a query, agent forwards the user query to an LLM. The LLM can decide if it needs to call tools or not. In this case, we have just a single tool, which is going to be a vector search tool to gather information to answer user questions. And everything that we did prior to this is to set up our data for vector search and that tool. So if it decides to call that tool, then the agent is going to call the tool selected by the LLM using the arguments that the LLM generates. So the thing to note here is the LLM only decides what tools to use and the arguments for the tool, but uh, it doesn't itself call the tool. That needs to be included as code as part of your agent. Okay, so if the vector search tool is called, it returns the IDs of the screenshots. So remember, in this case, we have screenshots sitting in blob storage, or in this case, local storage, and we have references in MongoDB. So the vector search tool is only going to return references to those screenshots. And then we have the additional step of reaching out to our blob storage, or in this case, reading those screenshots locally to actually get those actual raw images. And then we'll pass the user's question and the images themselves to the multimodal LLM. In this case, it's going to be Gemini, which is going to process both the natural language question and the images to generate an answer. And then I return that answer back to my agent, and it then gets forwarded to the user. So I know, super complicated, slightly complicated workflow, but we'll break this down into a series of steps, and hopefully that'll make things a bit clearer and easier to follow. Okay, so let's worry about one thing at a time. Let's first create the tools that our agent can use. So like I said, our agent has two objectives: to answer questions about this multimodal document, and then given a screenshot or figure, help the user make sense of it. So for that, we are just going to give our agent one tool, which is a vector search tool to get information to answer questions. So this is me defining a tool for the agent, and tools for agents are simply functions written in any programming language of your choice. So as you can see, it's literally a Python function, and this is going to become a tool for the agent. So the first thing you want to do in this vector search tool is generate an embedding for the user query. And few things to remember here. You need to generate an embedding because you are going to retrieve documents using vector search. So yeah, you've embedded your documents. You also need to embed your query. The other thing to remember is you need to use the same embedding model as you did to embed the rest of your data. So yeah, going to use the same helper function as before to use the same model to generate the embedding for the query. All right. And then I'm going to define something we call a vector search aggregation pipeline. So essentially, vector search is part of MongoDB's aggregation framework. And if you've never worked with aggregations in MongoDB, it's basically a series of data processing stages. So we treat vector search as a data processing stage. The one thing to remember is it always needs to be the first stage in a larger pipeline. So the first thing that happens is vector search, and a few parameters to pay attention to here. You want to tell it which vector search index to use. We are going to use the one that we created previously. Then the query vector, which is the embedded version of the user query. The path to the embedding, which is embedding in our case. This is the field where the embeddings of the documents are stored. Number of candidates, which tells it how many how many documents to consider to determine which ones are closest, and limit, which tells the vector search how many most relevant documents to return from this search. All right. And then we have a project stage, which is essentially used to just get only the fields that you need from your vector search document. So here I'm going to get the reference to the image, the width and height. I'll use this to load the image to a certain size, and the vector search score, just for you to see what the scores of each of the pages in the PDF look like. All right, so I've defined my pipeline. The next thing I need to do in this tool is to actually execute the pipeline. And finally, I need to get the references for the images so that I can actually load the images from local storage. So basically, I'm going to iterate through the results from that aggregation pipeline and get the key for the images and return those. So anytime this tool is called, you're going to get back the references for the images that you will need to load separately in your code. All right, so let's test out the tool with a sample query. So I'm asking it a question: what is the pass@1 accuracy of the DeepSeek R1 model on a certain benchmark? And I'm hoping that it'll give me the pages that are most relevant for answering these questions. So basically, it's telling me that page 13 and page 1 in the paper have relevant information to answer these questions. So yeah, that's essentially what I want my tool to do. So that's looking good. So in addition to actually defining the tool itself, for LLMs to be able to identify what tool to use and the arguments for the tool, you also need to give it like a function schema or a tool definition, function definition. You hear a few different terminologies, but essentially you need to give it like this JSON, like this JSON that tells it what the name of the tool is, a detailed description of what the tool does, and the parameters that it takes and what the shape of those parameters looks like. So in this case, my tool only takes a user query. It's of type string, and what does this parameter mean? So I need to create this kind of function definition, and this is what the LLM is going to use to be able to identify which tools to use when, and what the arguments for the tools need to be. So I'm going to set that. So next, I'm going to instantiate the multimodal Gemini LLM itself. So I'm going to use Gemini 2.5 Flash. Let's go ahead and run that. I'm going to instantiate the Gemini client. So I see a question, this one I can answer. Which agentic framework is used? So I'm not using any framework here. I'm trying to show you how to think about building agentic workflows from scratch without any framework, because frameworks usually tend to abstract away certain things. I just wanted you to get a good feel for what's happening under the hood. Okay, so I've instantiated that LLM. And with Gemini models, you also need to create a generation config. This could look different for different providers, but essentially, there's usually some way to tell the LLMs from these providers what tools to use, and then parameters such as temperature. You can set max number of input and output tokens, things like that. But with Gemini models, the way to do this is using a generation config and passing that to the model during generation. So first, you create the tools that the models can use, and then You create that generation config. This is where you tell the model what tools it has access to. And I'm also going to set temperature to 0 to try and get as deterministic responses as possible from the model. So I'm going to go ahead and run that. Now, there's two parts to my agent. So each time I get a user query, the first thing I'm going to do is call a function which uses an LLM to determine whether or not a tool needs to be called to answer that question. So this is what I'm going to do here. And then as I mentioned before, the LLM itself, it only identifies what tool to call and what parameters, but it doesn't really actually execute the tool. So I need to take care of that in my code as well. And these two steps together, so what's in task 11 and 12 together forms the logic for my agent. So yeah, the first thing we want to do each time a user query comes in is give the LLM the control to decide whether or not a tool needs to be called to answer the question. And so to do that, again, I'm going to write a simple function. It's going to have a prompt to an LLM. Here it says, based on the given function, decide which tool to use. I'm giving it a little more detail to help it make that decision, which is to say, if the user is just asking to explain an image, maybe you don't need to use a tool. And then this is where we are going to fill in the user query. So yeah, we don't have that in the prompt, but we'll see how to add that to the input. So basically, the input to the LLM is going to be this system prompt, and then messages, which is the user query, or maybe we don't have time for this, but any chat message history, all that is going to go in these messages. So these two together are going to become the input to the LLM. So essentially, yeah, you pass this system prompt and any chat history and current user queries as input to the LLM. And what you're going to get back from this generation call is whether any tool needs to be called and what the arguments of that tool are. So that's the function. And then here's the second part, which is the logic for the agent to actually execute the tools and get information from those tools and make another LLM call to actually generate the final answer for the user query. So here's my final flow of what happens when a user query comes in. So user query comes in. The first thing we want to do is make a call to the select tool function to see if the LLM wants to use a tool to gather more information. And if in our case, we only have one tool, so if the tool call is that vector search function, then we want to go ahead and actually call the tool at this point. So we are going to call the tool with the arguments generated also by the LLM. And remember that what you're going to get back from the tool call is just the references for the images. So we are going to, I think I'm missing a step here, if I'm not wrong. Oops. Okay, let's. Oh, okay. Yeah. So I'm going to get the references to the screenshots. I'm going to add that to any additional images that the user might have entered in their query. And then this is the system prompt for the LLM, for the second LLM call, which is to actually generate an answer to the user question using any information from the tool. So it says answer questions based on the provided context only. The context here is going to be the user query and information obtained from any tool calls. If you don't have sufficient context, say I don't know. So for this LLM call, the contents are going to be this system prompt, the user query, and any images that were obtained from that vector search tool. And at this point, I'm actually going to load the images so the multimodal LLM can actually see them. Right, almost there. And this is where we are passing all of this to the multimodal Gemini LLM, and we are using a different generation config here. Here we don't need the LLM to have knowledge of tools. All we need is that temperature setting, and then we are going to read the LLM's natural language response from this response, and that's going to be the final answer that we return to the user. All right. Rate limit, I think you need to, is that for Gemini? Okay, it's for embeddings. I think you need to put in your credit card information. No, it'll still give you 200K free tokens, but I think you need to put in that information to get those free tokens at least. Okay, so final thing we want to do is actually execute the agent to see what happens end to end when a user query is given. So this is what's happening here. And let's test that with a few test queries. So here, again, trying that same question that we used to test our tool. So as you can see, the agent is calling the vector search tool. I don't know why it's saying I don't know. Let's maybe try running that again. But it at least got the right images from our tool. And well, this is a lesson in LLMs just being finicky. So these images were passed to the multimodal LLM, and it gave me a response back. And let's finally test what happens for this query. So here I'm just asking it to explain an image. So it shouldn't really call any tools. Yep, it didn't call a tool. It's just going to give me directly an explanation of what this image is about. All right, I know I'm coming up on time. I do want to leave some time for questions, but in your notebook, you should also see an additional task, which is adding memory to the agent. This is where you also give agent access to its past interactions. And this is mainly important for the agent to have consistent, coherent dialogue with its users across multiple conversations. So definitely encourage you to go check that out and work on this section after this code along as well. But yeah, I'm going to stop here for now. We have some time for questions, so let's take those. I'm going to stop sharing, I think.
Sorry, my bad. I was on mute.
I don't think I can hear you.
How's that? Lovely.
Yeah, I can hear you now.
So yeah, we've got a couple of questions from the audience. It might be worth getting the screen share back up because I think a lot of these are
related to the code. Okay.
Related, yeah. So first one is from Sunil. This one was fairly early on, I believe, and he said, we can chunk the text and train it right. Can you let us know what are the key main advantages by converting each page into a screenshot? I think we did already cover this maybe when it came up, but just for anyone that missed it.
Yeah, so let me go back to these slides, right? So basically, typically, you think about chunking in the context of text-only data. That's where you are working with just text, so you can chunk that data easily. But if you have text and then a few images and tables, then it doesn't really make sense to like chunk images and tables. So in that case, you want to be able to keep some amount of text together with images and tables, because typically, if you look at even this research paper, the text surrounding an image or table is going to have relevant information. So you want to be able to keep all of that together. So in this case, purely chunking is not going to work, which is why a screenshot is an attempt to keep all of this information together.
Got it. Okay. Next one was, well, a little bit more of a comment, but someone from LinkedIn saying floating point numbers are numbers of dimensions. Is this similar to the cosine function? Do they have tangential functions too? A little bit mathsy for me.
Floating point numbers. Okay, by floating point numbers, I just mean, so if you, let's see, okay. So this is a floating point number. It's just not an integer. So it has some decimal points. So this is a floating point number. I was referring to embeddings being an array of floating point numbers. And cosine is slightly different. So there's a few different ways to measure similarity or distance in vector space. This is how techniques like vector search retrieve information. And the way to do that is using certain mathematical functions. One of them is using cosine, which measures the angle between two vectors of floating point numbers that look like these. But there aren't tangential functions, but there's other functions like dot product and Euclidean, which are other distance metrics to measure similarity. So check those out.
Got it. Or I say got it. That went straight over my head, but hopefully people got it. Cool. Next question is from AV, and they say, when you create your embeddings, do you set a specific chunk size, or do you chunk size by a page number?
Yeah, so I think this is related to that previous question. So we aren't doing chunking in the traditional sense here. Here, my chunk is a single page in the screenshot, but
Right.
like as you can see, I didn't really chunk it. It's just yeah, I didn't chunk it.
A
Let's
bodge
just say
chunk.
that.
Yeah.
Yeah.
Cool. We had Praveen ask which agentic framework is used. Is that applicable here?
Yeah, and I did cover this as I was speaking, but I didn't really use an agentic framework here. There are frameworks in the market. My preferred one is typically LangGraph. There's also Crew AI, which is solid. But here, my goal was to show you what an agentic workflow looks like without any frameworks involved, just to get a good sense of what happens under the hood. Because the whole point of these frameworks is to abstract away some of these things that you need to do.
Got it. And then this next question was near the end. Is there any other way than generating embeddings? I think that was around task 12 or something.
Yeah, so here I'm assuming that, not assuming, here I'm intentionally using vector search to retrieve information for the agent to answer questions. But say you didn't use vector search for retrieval, then you don't need embeddings. If you're using if you're just matching on specific criteria, then you don't need to use vector search, which means you don't need to generate embeddings. Embeddings is only if you're using techniques like vector search.
Got it. Okay, that's it for questions from the audience at the moment. If you have any questions, please get them in soon because we've only got a couple minutes before the end of the session. However, in the meantime, I have a few questions of my own.
Mm-hmm.
So for those that are newer to AI apps, what kind of real world use cases can we apply this kind of architecture to?
So AI, and here we were building an AI agent, right? So if you think about AI agents, you're basically giving an LLM full control of coming up with what the plan of action needs to be to essentially solve a problem end to end, or at least that's the goal. So I would say apply agents to any problems where there is no the path from giving it a task to finding a solution is not completely obvious, which is why you see agents in use cases like code generation or even like full-fledged code solutions where they're not just generating code, but also looking at different kinds of documentation to be able to go from basically giving it a task to creating a merge-ready PR. So code gen is a good one. Then we see a lot of agent applications in places where the content creation is a good one. So reviewing content, making some basic improvements to it, like grammatical checks, punctuation checks, and then also passing it on to human reviewers. That's kind of like a hybrid agent and human workflow. But we also see agents play a big role in like automation. So like there you might not have a strictly agent workflow, but these get into agentic workflows where they are still automated workflows, but LLMs might not have full control. So there's a few different types of things where you see agents being used.
Cool. And yeah, we've obviously got lots more content coming up on agents in our upcoming live event roadmap. So yeah, if you do want to find more info, plus we've got more short courses coming as well. So please do check out our future events on datacamp.com/webinars. We flew through this session pretty quickly in, what was the span of like 45 minutes. When it's a different case putting it all together, what was the hardest part of getting everything to work together in building this session?
In building the session specifically?
Yeah, or just in general, putting together use case like this.
I think just building it in a way. I think the hardest part I find about building sessions like these is like people come to the session with different levels of expertise and experience. Like for example, here I didn't really go deeply into like what an AI agent is, what are embeddings, but yeah, you have like limited time, so you kind of need to pick and choose what you're going to focus on. But yeah, I think it just makes me slightly uneasy knowing that I might lose some people in the audience.
Yeah, fair enough. And I think we've got time for one question. So if someone wanted to start using this, but using their company data, what sort of concerns might they need to think about? Yeah, what do you need to think about if you're thinking about applying things like this to your own company's data?
Yeah. So security and data security and privacy is a big one when people are working with LLMs and basically applying LLMs to their company data. So I think that's a big one to pay attention to. So which is why I say that working with LLMs is still a data processing problem first and foremost. And I showed that in this code along. We spent a lot of time on data processing. So even there, like try to sanitize, clean your data as much as possible. Typically there's legal teams and teams just working to create like some framework for how LLMs can be used as an organizational level. So pay attention to what your company policies are. They'll tell you not to put any sensitive data into LLMs, but if you have to use them, then try to find LLMs that at least try to give you some explainability or mitigation measures for what to do when things go wrong. So yeah, security is a big one and all considerations that come with it.
Brilliant. Okay, and that takes us up to time. So yeah, thank you so much for the session today, Apoorva. As much as I might not have understood everything, I think everyone in the audience learned a lot. So yeah, thank you so much for putting together such a nice notebook. And yeah, for anyone else that enjoyed today's session, please do check out our upcoming events. As I previously mentioned, you can head over to datacamp.com/webinars, where you'll find all of our code along sessions, as well as all of our webinars as well. We've got a webinar tomorrow and a webinar on Thursday. Tomorrow, we're talking about learning communities for training. And then on Thursday, we're talking about the 4 tenets of data teams. And then we have our next code along, I believe, is on the August 5th. And that will be grounded vibe coding with MCP and Qdrum. So yeah, if you want to join up there, head over to datacamp.com/webinars. But again, thank you so much for everyone that joined. Thank you, Apoorva.